Okay. So in the last class, so I was talking about data types. So I was talking about data types, and I said data types are used. So I said data types are used in order to allocate or reserve space for data within memory. And I said Python data types are classified into two categories. One is called standard data types, and one more is collection types. And I said data type defines for which type of data how much memory has to be allocated. And I said Python data types are classified into two categories. One is standard and one more is collections. And these are called standard data types like integer, float, complex, boolean, and one more is none. And collection types are also called as a data structures, which are used to represent more than one value. So integer represent only one integer. If you want to represent more than one integer, then go for which one? Collection. Okay. So I said there are 14 data types are there. These are called Python fundamental data types. Every collection type is called one data structure. A data structure defines some set of rules and regulations. I said Python is object-oriented programming language. Object-oriented is not a language. It is a programming paradigm. What it defines some set of rules and regulations to organize data and instructions. In object-oriented programming, data is represented as what? Objects. And every data type in Python is a class, and data is represented as objects. So a Python fundamental data types are exist in one predefined library or module called which one? Built-ins. I said every data type is a class, and data is represented as what here? Objects. I just give you the brief idea about what is this class and object is, because every data type in Python is a class. Every data type in Python is a class. Every data type in Python is class. Okay, and these classes are two types. One is predefined classes. Okay, these classes are two types. One is predefined classes, and one more is what? User defined classes. So how many types of classes are there here? Two types. Two types of classes are there. One is the predefined classes, and one more is user defined classes. So existing classes are called existing classes are called which classes? Predefined classes. Are the classes provided by the classes provided by Python are called predefined classes. Example is like int, float, boolean, okay, string, list, tuple like this. All these are which classes here? Predefined classes. Predefined classes, or you can call it as predefined data types. User defined classes or user defined data types. So the classes developed by programmer are called user defined classes. Example is I build my own class called student. I build my own class called employee. I build my own class called product. Okay. So the classes are two types. One is predefined and one more is what here? User defined. So existing classes are called predefined classes. See any class, either predefined class or user defined class. Okay, see existing classes means I said, like suppose you develop a class. If you develop a class, for you it is which class? Predefined class, user defined. And for me it is what here? Predefined. If you develop a class, for you it is what? User defined. For me it is what? Predefined. If I develop a class, for me it is what? User defined. If I give it to you, it will become what? Predefined. But either predefined class or user defined class, either it is predefined class or user defined class, it is defined by somebody. Either it is predefined class or user defined class, it is defined by somebody, right? Because every class can be called as user defined only. Somebody else developed the class, and if you are using it, then it is called as predefined. If you are developing your own data type or class, then it is called as what? User defined. It is like that. Okay. So every data type in Python is a class and data is represented as what? Objects. Every data type in Python is a class and data is represented as objects. So why? Because Python is which language? Object-oriented programming language. So every data type in Python is a class and data is represented. Data is represented as what here? Objects. Data is represented as a object. Every data type in Python is a class and data is represented as a objects. So then what is, so first we'll see what is object is. What is object is. So generally you'll say this object is an instance of a, object is an instance of a class. What is object? Object is an instance of a class. You can say object is an implementation of which one? Class. Object is an instance of a class. Object is an implementation of what? Class. Object is an instance of a class. Object is an implementation of a class. Data in object oriented data in object oriented is represented as what? Object. every object every object every object is having two characteristics. Every object is having two characteristics. Okay, every object is having two characteristics. One is called properties. These properties can be called as attributes, and having behavior. So behavior is nothing but here functions. Every object is having two characteristics. Data in object oriented is represented as what? Object. Every object is having two characteristics. One is properties, or it is called as which one? Attributes. And second one is called as which one? Behavior. So behavior is nothing but functions. So every object is having attributes and functions. So here properties defines the state of the object. Properties define the state. State is nothing but values. State is nothing but values of the object. And behavior defines the functionality or operations of which one? Object. Properties define the state or values of the object, and behavior defines the functionality or operations of what? Object. So in order to develop an object, in order to create an object, in order to create object, what you require here? Class. In order to create an object, what you required? A class. To create object, what you required? A class. So what is a class? Class is a class is a blueprint. Class is a blueprint of object. Class is what your blueprint of object. Now class is a data type, okay, which is used to allocate memory for which one? Object. So class is encapsulated with properties and behavior of object. Class is encapsulated with properties and behavior of object. So class is a blueprint of the object. Class is a data type which is used to allocate memory for object. Class is encapsulated with properties and behavior of what? Object. Class is encapsulated with properties and behavior of object. Or you can say class defines the structure of which one? Object. Class defines the structure of the object. Class defines the structure of the object. Grouping. Encapsulating means grouping. Class is encapsulated with the properties and behavior of object. Or class defines the structure of the object. So what is the meaning of this here? For example, for example, a simple example I'll tell you. A simple example I'll tell you. Assume that, okay, assume that, okay, so assume that I'm developing one application or I'm developing one game. Okay, some robo game. I'm developing one game. What is that game here? Robo game. In robo game, so there are different robos in my game. I want to construct different robos. So before creating robos, first what I'm doing, I'm designing robos. So designing is nothing but, here it is a class. Okay, designing is nothing but what here? Class. Designing is nothing but class. I'm trying to develop a class. What is the name of the class here? Robo. What is the name of the class here? Robo. Robo is a class name. Robo is what here? Class name. Robo is a class name, or same thing you call it as data type name. So what is the name of the data type here? Robo. What is the name of the data type here? Robo. Okay. And every robo is having some properties. What are the properties of robo is? Robo is having a name. Okay, what is the name here? Attribute. Okay, is a property name. And robo is having a name, and robo is having what? Color. So every robo is having how many values? Two values. Robo is having how many values? Two values. One is the name of the robo, and one more is color of the robo. So what is this name and color? What is this name and color are called? Properties. This name and color is called what here? Properties. And the robo is also having behavior. Behavior means what? Functionality. Like a robo can talk. Talk is a function. Okay, robo can walk. Walk is what again? Function. Okay, talk is a function. Walk is a function. Okay, run is what again? Function. So robo is having two attributes. One is a name and one more is what? Color. Robo is having two properties. One is a name and one more is a color. I said class is a data type. Class is a data type, and class is a blueprint of which one? Object. So once you design a class or once you develop a class, using this class, you can create any number of robos. Creating robos is nothing but objects. Creating robo is nothing but what here? Objects. As an object is an implementation of a class. So you are allocating memory for robo 1. So what is this robo 1 here? Object. What is this robo 1 here? Object. Okay, then using robo class, I'm trying to create another object. I'm trying to create another object. What is that another object here? Robo 2. So whenever you create the object, the memory is reserved for attributes. So robo 1 is having how many attributes? Two attributes. One is a name and the other one is what here? Color. Robo 2 is having two attributes. One is a name, the other one is what here? Color. Okay, assume that the name of this the name of this robo is some Chitti 1.0. Okay, and the color is, I just write it as what? White. And the name of this robo is Chitti 2.0, and the color is what here? Black. Okay, now data is represented as what here? Objects. Now what is this robo 1 and robo 2 are this both are called as which one? Objects. So in order to create an objects, first you have to develop a class. So class and then what here? Objects. Now, is it robo is a user-defined class or predefined? User-defined. Robo is a predefined class or user-defined? User-defined. So class is a data type, and object is an implementation of which one? Class. In object-oriented application development, yes, that is what I said. You are always using a class to create what? Objects. Always you are using a class to create the objects, and you are creating objects in order to store the data, and perform certain operations. Storing the data and performing certain operations. So here, if you take integer is there, what is the name of the class? Integer. What is the name of the class? Float. What is the name of the class? Boolean. But all these are predefined classes are not? Yes. But what is the name of the class here? Student. So integer allocates memory for which one? Integer object. Integer allocates memory for which object? Integer object. Float allocates memory for which object? Float object. So Boolean allocates memory for which object? Boolean object. And student class allocates memory for which object? Student object. Okay, student object. Okay, yes. I said class is a blueprint of the object. So robo 1 is having how many functions? 3 functions. What is that? Talk, walk, and run. Robo 2 is having how many functions? 3 functions. Talk, walk, as well as what? Run. Robo 1 is having how many functions? 3 functions. Robo 2 is having how many functions? 3 functions. Robo is having how many functions? 3 functions. That can be Robo 1 or Robo 2 or Robo 3 or any Robo, right? Having how many functions? 3 functions. Okay. Yes. Now these functions you'll be calling on these objects. These functions you'll be calling on these objects. If I say Robo 1 talk, then Robo 1 will talk. If I say Robo 1 walk, then Robo 1 will walk. If I say Robo 1 run, then Robo 1 will run. If I say Robo 2 talk, then Robo 2 will talk. If I say Robo 2 walk, then Robo 2 will walk. If I say Robo 2 run, then Robo 2 will run. But whenever you create the object, the memory is allocated only for the data. When you create the object, the memory is allocated for only attributes, but not for the functions. Because these functions you call on these objects. These functions you'll be calling on these objects. These functions you'll be calling on these objects to perform certain operations. For example, yes. So class is a blueprint of the object. Class is a blueprint of the object. Okay. For example, there is a class. Okay, now assume that there is a class. The name of the class is a stack. Okay, what is the name of the class stack? Stack is a class name. A stack is a class name, and stack is which one here? Data type name. Okay, so this is a data type name, or it is a class name. It is a data type name, or it is a class name. Now stack is having a data. Okay, okay, suppose data type and class name. Now stack is having which one? Data. So what is the property name here? Data. And this data you are operating it by using some functions. Now stack is having a functions like what is that? Push. Now stack is having a function called which one? Pop. When I say push, it will add the data to which one? Attribute called which one? Data. If I say pop, it will remove the values from which one? Data. So stack is doing how many operations here? 2 operations. One is a push and one more is what? Pop. Now stack is a class, and using the stack class, I can create number of stacks. Okay, assume that there is a stack 1. Okay, assume that there is a stack 1. There is a stack 1. What is stack 1 here? Object. Okay, there is another stack. Okay, there is another stack. And what is that another stack here? Stack 2. So there's a stack 1 and stack 2. So whenever you create the object, the memory is allocated for data. Whenever you create the object, the memory is allocated for which one? Data. So if you want to add the data, then you are calling which function? Push. You'll be saying like this. Okay, stack 1 dot. You'll be saying like this, stack 1 dot. Dot is nothing but member access. You're saying stack 1 dot push. It means you are calling the push function of stack to add the data into which object? Stack 1. Okay. If I'm trying to say stack 2 dot push, you are calling the push function of stack to push the data into which object? Stack 2. So always you'll be calling the functions on which one? Objects. If I'm saying stack 1 dot push, you are calling the push function on which object? Stack 1 object. If I'm saying stack 2 dot push, you are calling the push function on which object? Stack 2 object. So object is having what? Data, and the data you are operating in with the help of what? Functions. The object is having data, the data you are operating in with the help of what? Functions. Ring or not? Okay. Yes. So every data type, you'll be developing your own classes that you learn in the second part, that is an object oriented programming. So second part, advanced Python, you learn how to develop your own classes, how to develop your own classes, and how to implement polymorphism, inheritance, okay, encapsulation and everything. But meanwhile, just try to understand what is a class and what is a object is. So class is a blueprint of what? Object. And class is a data type which is used to allocate memory for what? Object. And class is encapsulated with the properties and behavior of object. And class defines the structure of what? Object. Class is a blueprint of the object. So here, class is a blueprint. Class is a blueprint of which one here? Object. Once you develop a class, no rule. I didn't say any rule like that. First letter is capital, second letter is capital. Okay, yes. I said int is a class. Is it first letter is capital? Int is a class only, right? Is it first letter is capital? No. So don't implement Java things here, right? Okay, don't be confused. Don't be confused. Okay, if anything is there, I'll tell you. Okay, right. So class is a blueprint of what here? Object. Class is a blueprint of object. And class is a data type which is used to allocate memory for the object. Class is encapsulated with the properties and behavior of object. Class defines the structure of what? Object. Class is a blueprint of the object. So blueprint is, if you want to develop a class, you should know what is your object is. Until unless you don't know what is your object is, you cannot develop a class. Until unless you don't know what is your object is, you cannot develop a class. You cannot develop a class. Okay. For example, a person want to construct the house. A person want to construct the house. House or houses. A person want to construct the house. Constructing house is nothing but what here? Object. So before constructing the house, what he'll do? He'll go for house planning. Before constructing the house, he'll go for which one? House planning. So this house plan is nothing but what here? Class. House plan is nothing but what here? Class. Class is a logical. Class is a logical, but object is what? Physical entity. Class is a logical entity. Object is what here? Physical entity. I cannot, suppose this is house planning. This is house planning. House plan. Assume that this is a house plan. So house plan is only blueprint of the object. House plan is only a blueprint of which one? Object, where you'll try to define where is a hall, okay, where is a hall, where is a kitchen, like that. Okay, I'll try to define certain things here. Okay, this is only house plan. This is only house plan. This is only house plan. right? You are trying to define the structure of house. You are trying to define the structure of the house. Now that you can call it as which one? House plan. Now can you live inside house plan? Huh? No, you cannot live inside house plan, right? It is only a blueprint. Can I sleep in bedroom here? No, there's no bedroom exist. Because is it a logical or physical? Logical. It is not a physical, it is a logical, right? Now, in order to implement this, what you required? In order to implement this house plan, first I required some space. I required a space or not? Yes, I required a space. And within this space, I try to implement it. Within this space, I'll try to implement. Within this space, I try to implement it. So object is to implement. Object is an implementation of a class. Object is an implementation of which one here? Class. So I can live inside house, but not in the house plan. This you can call it as which object? House one object. This is house one. House one is an instance of which one? House plan. Now using this house plan, can I construct any number of houses or not? Yes. Using this house plan, I can construct any number of houses. Using this house plan, I can construct any number of houses. There is a house one and there is a house two like that. Okay, there is a house one and there is a house two like that. So this house one and house two, these are called as which one? Objects. So I can live in house one. I can live in what? House two. But I cannot live in what? House plan, because it is only logical entity, but constructed houses are what? Physical entities. This is a logical entity, but this is what here? Physical entity. What it required? Some space. To create object, what you required? Space. Okay. Object required a space, but class doesn't require a space, because class is only logical, but object is what here? Physical. Okay. So generally, every data type, that is what I said. Every data type is a class, and the data is represented as what? Objects. Every object is having. Now, sometimes they ask you like, every object is having, what is SBI? Sometimes they ask you, what is SBI of an object? What is SBI of an object? SBI. So SBI stands for, SBI stands for, S stands for here. Every object is having state. B stands for, okay, behavior, and I stands for identity. I stands for what here? Identity. Every object is having these characteristics. Okay, state, behavior, and object. So the state is nothing but, state is a data stored within object, that you can call it as state. So behavior is a functionality of which one? Object. Identity. So every object is identified with some name. Every object is identified with a name. Now this is to differentiate one object from another object. This is to differentiate one object from another object. This is to differentiate one object from another object. Okay, right? So this is how it is. Now let us talk about the predefined data type called which one? Int. So class names are not keywords. Class names are not keywords. Class names Class names are not keywords. Okay, ring or not. So how can you find out the keywords? Import keyword module and print which one? Keyword dot keyword list. So in this, you find any keyword called int? Is it any keyword called int in this? No, there's no keyword called which one? Int. Is it any keyword called float? No. But if you want to write a class, you can develop a class by using the keyword called class. You can develop a class by using the keyword called which one? Class. So open ideally. If you want to develop a class, you can develop a class by using, okay, keyword dot keyword list. Now, if you want to write your own class, you can write your own class by using which keyword? Class keyword. You want to develop a class. You want to develop a class. What is the name of my class? Name of the class or name of the data type? What is the name of the data type? A robo. Okay, robo is the name of the class. Robo is the name of the class or name of the data type. So this is what name here? Data type name. Okay, and this data type is having how many attributes? Now robo is having how many attributes? Two attributes. One is a name and one more is what? Color. And it is also having some functions, right? It is also having some functions. It is having functions called what is that? Walk. It is having a function called which one? Talk. It is having a function called which one? Run. Now once you develop a class or once you develop a data type, using this data type, you can create what here? Objects. Using this data type, you'll create the object. So is it robo is a user defined data type or predefined data type? User defined. But int is what? Predefined. Predefined class. Predefined class means it is also user defined or not? Yes. But who provided that class? Python. Okay. So class names are not keywords. Class names are not keywords. Class names are what here? Class names are what? Identifiers. Class names are not keywords. Class names are what? Identifiers. Okay. So just try to understand this. It's very simple, right? So let us talk about. So let us talk about int class. Let us talk about int data type or int class. Int data type or int class. So already I said you, like in the beginning, Python is a dynamically typed language. Python is what? Dynamically typed language. Okay. I said in the beginning. Okay. I said in the beginning. Okay. Python is a, I said in the beginning, Python is dynamically typed language. Dynamically typed language. When I'm saying dynamically typed language, in dynamically typed languages, variables are not bind with one type. Variables are not bind with one type. In dynamically typed languages, okay, variables are not bind with one type. Variables are not bind with one type. A data type is not defined explicitly. Okay, data type is not defined. Data type is not defined explicitly. In dynamically typed languages, variables are not bind with one type. A data type is not defined explicitly. Okay, for example, if you are working with programming languages like C or C++ or Java, okay, if you are working with C, C++ and Java, so these are called which languages? Statically typed languages. Statically typed languages. Okay, these are called statically typed languages. So when you're saying it is a statically typed languages, in statically typed languages require the data type explicitly. It means if you want to allocate memory, you need to take the help of which one? Data type. We'll say integer, some A. We'll say integer and what? A. Integer A. What is integer here? Data type. What is integer here? Data type. Integer is a data type. And what is A here? Variable name. So A is a variable name. What is variable? A variable is nothing but, yes, what is variable here? A variable is a named memory location. What is variable? A variable is a named memory location. So here A is a variable name. Identifier. Variable is nothing but identifier. Variable is what here? Identifier. Variable is an identifier or it is a named memory location. Named memory location. So assume that this is a RAM. Okay, what is this here? RAM. Okay, within the RAM, I want to store the data. Within the RAM, I want to store the data. Okay, if I want to store the data within the RAM, I have to reserve some space. But how I am reserving the space? With the help of data type. So what is the name of the data type? Integer. So integer will reserve some space. This data type will reserve some space. Assume that it reserves the space of some 2 bytes or 4 bytes. Assume that it is reserved the space of how many bytes here? 4 bytes. And after reserving a space of 4 bytes, to this location it gives one name. What is the name of this location? A. So what is the name of this location here? A. Can you say A is a variable name or not? Yes. So variable is nothing but named memory location. Variable is nothing but named memory location. If I'm writing if I'm writing A equal to 60, then this 60 gets stored in a location whose name is what? A. So here the data will be stored. 60 is stored inside what? A. If I want to change it again, I'll say A equal to 70. So here the 60 is modified. The 60 is modified to what here? 70. This is what will happen. If you want to manipulate the data, you reserve the space and then you manipulate what here? Data. But when it comes to a C, C++, Java, you do like this. So variables are created with the help of which one? Data type. It means variables bind with one type. Variables bind with what here? One type. But when it comes to a dynamically typed language like Python, dynamically typed language like Python, dynamically typed language like Python, what will happen? What will happen? See, A is always which type? A is always which type? Integer type. For example, if I'm trying to say A equal to 1.5, what is 1.5? Float. Then immediately the C++ or Java compiler generates what? Error. Because A is which type here? Integer. And it can hold which type of value? Integer value. But it cannot hold which value? Float value. Because I declare A as which type here? Integer type. Then it can hold the value of which type? Integer type. But it cannot hold the value of which type? Float type. It can hold the value of integer type, but cannot hold the value of which type? Floater type. But when it comes to a dynamically typed languages, variables are not bind with one type. Variables are not bind with one type because you create a variable You create a variable by just assigning what object. For example, if I assign integer object, then A is which type? Integer type. If I assign a float object, then A is which type? Float type. If I assign the string object, then A is which type? String type. But is it A is declared with any type? No. So here there is a declaration. In C, C++, Java, there is what here? Declaration. You declare A is which type? Integer. But in dynamically typed languages like Python, you don't declare. There's no declaration. There's no declaration. You don't declare a variable as this type. You don't declare variable is this type. Okay. Here you are declaring A is which type? Integer. But here you are not declaring it. You're not declaring A is integer. But A is which type? That is based on the type of object you assign. If you assign integer, then A is B, which type? Integer type. Okay, if I assign float, then A is which type? Float type. Means it is not bind with one type. The type changes. It is not bind with one type. The type changes based on the type of object assigned. The type changes based on the type of object assigned. That is what you mean by dynamic. For example, if I'm saying A equal to 10, if I'm saying A equal to 10, then A is which type? Integer type. Because 10 is a value of which type? Integer type. If I'm saying A equal to 1.5, if I'm saying A equal to 1.5, now A type is changed from integer to what? Float. Okay, A type is changed from integer to what? Float, because A is holding which type? Float type. But first it is holding which type? Integer. But later the A is changed from integer to what? Float, because there is no declaration. Because there is no declaration. There is no declaration. Okay, here type is integer, and here type is changed from integer to what? Float. In dynamically typed languages, there is no declaration. In dynamically typed languages, there is no declaration. Okay, you don't declare a variable with a type, because the type is defined based on the object assigned. Okay, so it is not bind with one type. Variables are not bind with. In dynamically typed languages, already I've written here. In dynamically typed languages, variables are not bind with one type. Or data type is not defined explicitly. In dynamically typed languages, variables are not bind with one type. Data type is not defined explicitly. You simply write A equal to 10. Okay, then type of A. I want to check which type of A is which type. A is holding which type of object is. Now A is which type here? Integer. What is the name of the class? Integer. Okay, what is the name of the class? Integer. If I'm saying A equal to 1.5, A equal to 1.5, then previously A hold which type? Integer type. Now this time A is holding which type? Float type. Now, is it type is get changed from integer to which one? Float. Explicit means you create, you give. Okay, you declare it. You are declaring explicitly giving A is which type? Integer. But are you giving anything before A like integer A? Are you giving here integer A? No. But in C, C++, Java, you have to give. Explicit means you have to give. Explicit means you have to give. Implicit means automatic. Explicit means you have to give. If I'm giving here integer A, what will happen? If I'm writing integer A, what will happen? Is it the syntax is allowed or not allowed? Not allowed. The syntax is not allowed. Immediately it is given which one? Syntax error. Okay, this syntax is allowed in C, C++, Java, but it is not allowed in what? Python. I cannot write integer A. I cannot write float A. If I'm trying to write integer A or float A, immediately it is given which error? Syntax error. But is it the syntax is valid when it comes to a C, C++, Java or not? Yes. So declarations are allowed there, but here declarations are not allowed. Only creation. But that creation is based on the value what you assign it. Okay. Yes. Now there is a first data type is integer. So it means how you allocate, how you create a variables in Python. How you create variables in Python? You create variables in Python by assigning what? Object. You create variables in Python by assigning which one? Object. But in C, C++, you have to declare. You have to declare it with the help of what? Data type. But here, no. You just assign a value. You just assign the value to a variable. Then your variable get what? Created. So first one is integer data type or class. Okay. Integer predefined class. Integer predefined class or data type. Okay, which is used to allocate memory for to allocate memory for to allocate memory for which object? Integer object. Integer predefined class or data type. Integer predefined class or it is a data type. Integer predefined class or data type which is used to allocate memory for integer object. So it is a predefined class. Integer is a predefined class or data type which is used to allocate memory for which object? Integer object. Okay. Yes. But here integer is an immutable data type. Integer or int is an immutable data type. What is immutable data type? Constants. Immutables are nothing but constants or immutables. Immutables are constant. Immutable is a constant whose values whose values never whose values are never changed. So after creating integer object, we cannot we cannot modify we cannot modify what? Values. After creating integer object, we cannot modify values. So immutable is a constant whose values never changed. What is immutables here? Immutables are constants whose values are never changed. Or after creating integer object, we cannot modify the values or we cannot change the values. So the size of integer data type is the size of integer data type is unlimited length, unlimited length because every data type is dynamic actually. For example, integer, if you see integer in C, C++, if you take integer in C, C++, integer data type allocates how many bytes here? 4 bytes, means fixed size. The data type sizes are what here? Fixed. Now integer reserves memory of how many bytes here? 4 bytes. But in Python integer, what is the size of integer? What is the size of integer in Python? Unlimited length. Okay, unlimited length. I can reserve the space of any length. What I mean to say is I can store a big value also. I can say A equal to this much big value, I can store it. This is having more than 30 digits. Now my number is having more than 30 digits. That much very big value also I can store it. So it is with unlimited length. It is with what here? Unlimited length. Unlimited length. Unlimited length. That is what the meaning of the size of integer data type is unlimited length. But the size of data types in C, C++, Java is fixed length. That's the reason you find multiple data types in C, C++, Java. For example, if you want to reserve the space of 1 byte, then you'll use a data type called which one? Byte. If you want to reserve the space of 2 bytes, you'll use a data type called which one? Short. If you want to reserve the space of 4 bytes, you'll use a data type called which one? Integer. If you want to reserve the space of 8 bytes, then you'll use a data type called which one? Long. So in C, C++, Java, in Java, how many integer data types are there? 4. In Java, how many integer data types are there? 4. Byte, short, int, long. Because byte will reserve the space of how many bytes? 1 byte. And short will reserve the space of how many bytes? 2 bytes. If you want to store the integer value which is more than 2 bytes, I'll go for which data type? Integer, which is 4 bytes. If I want to reserve the memory of more than 4 bytes, then I'll go for which one? Long, which is 8 bytes. But how many integer data types are there in Python? Only one. How many integer data types are there in Python? Only one. What is that? Int. Okay, what is that? Int. Int. Only one integer data type is there in Python. What is that? Int. Because this data type reserves memory of which one? Unlimited length. So it allows both. It allows integer data type. Integers. I think you know integers are numeric values. Integers are what? Numeric values which doesn't have any precisions, decimal points, right? Integers are whole numbers, integers are natural numbers. Okay, integers which doesn't have any decimal point. That value is called as which one? Integer value. No, there's no data types like double, long, no. In Python, you don't have all those data types. Okay, so integer is a numeric value. Integer is a numeric value which doesn't have what? Decimal point. Which doesn't have a decimal point. Yes, both. Integer allows both. Integer data type allows both. That is signed values, signed and unsigned. Signed means negative, positive, unsigned means only positive, right? You can say positive, or you can call it as what here? Negative. Positive values, it accept positive values as well as what here? Negative values. It accept both the values, positive as well as what? Negative. So how can you allocate memory for integer data? Okay. So memory for integer, see, integer object is created in two ways. Okay. Integer object is created in two ways. One is by assigning integer value, to by assigning integer value to a variable, and second one is using int class by assigning integer value to a variable, and second one is using integer class. You can use directly integer class. We'll discuss that. Manish. We'll discuss that.